So another typical projectiles type question where we're kicking a ball over horizontal ground. Let's see how we get on with this one. So here's this question. I'm going to start by just drawing myself a little diagram as usual. So there's our angle theta and the initial velocity of 12 meters per second. And the particle, the ball, is going to do something like this. And we are told that the maximum height is 5.5 meters. So if we take the vertical direction and we look at the time when it gets to that point, we know the displacement will be 5.5 when the final velocity is 0 vertically. So displacement is 5.5 when the final velocity is 0. We're not interested in the time at this moment, and the acceleration in that direction is minus 9.8 because gravity is in that direction, and the initial velocity is 12 sine theta vertically. So I need the formula that doesn't have time in it. V squared equals u squared plus 2as. And then when I put those values into the formula, I get that, from which I can calculate the value of sine theta. Now, I suppose I should just for a moment think that, well, when we take the square root, we should be thinking about positive or negative. But if we were interested in the negative theta, that would give us, or negative sine theta, that would give us a negative theta as well, which would mean we'd be kicking the ball into the ground, which is impossible. So that's why I'm only considering the positive value of sine theta here. So that gives me a theta of just under 60 degrees. Okay, so now what we're trying to do is to find the height of the ball when it's traveled a horizontal distance of 4 meters. So using the horizontal distance of 4 meters, I can work out what the time is that it takes to get to that point. So 12 cos theta, which is the horizontal velocity, times the time that it takes to get to that point is equal to the displacement of 4 meters. So from there, using theta that I calculated a moment ago, I find that the time that we're interested in is that number there. I'm writing it down to more decimal places than can be justified, but I don't want to incur any rounding errors unnecessarily. And then I can look at the vertical displacement again, the vertical movement. And vertically, I'm looking for the height of the ball, so that I'm calling that S. The initial velocity is in the vertical direction is 12 sine theta again. Not interested in the final velocity this time. Acceleration minus 9.8 again, and that's the value of t which I calculated there. So I need the formula that doesn't have v in it. S equals ut plus half at squared. And when I put those values into there, including the right value for theta, then I get a displacement of 4.74 meters. So there we are. What about the final part of this question? In what ways is the problem simplified by modeling the ball as a particle? Well, it's a very interesting thing to do, very helpful thing to do when we're modeling. Not terribly realistic though, because we've not had to include air resistance, we've not had to include any rotational effects, and we don't need to include the size of the ball by modeling it as a particle. So a number of things that make our life easier but the easier it is, the less realistic it is. So there we are.